So, welcome to the video lecture series on syntax directed translation on assignment statements. So, this assignment statement is connected with principles of compiler design subject. So, we will be learning about the various syntax rules which is connected with the productions, and we will also use certain examples, and we will also look into how to actually apply this semantic rules in transforming our high level expression to a 3 address code. So this is Dr.K.N.Sivabalan. So we'll look into about assignment statements. The assignment statements prominently deals with expressions. So an expression can be of any type. For instance, it can be an integer expression or real expression, or otherwise it can be composed of records, and in sometimes an expression can contain arrays also. And emit is a procedure or a function which appends the 3 address code to the output. In short, emit is used to generate a 3 address code for the corresponding high level statement. New temp is also called as a function which generates a temporary variable. And we will also learn about the attribute associated with E. So E is called as an expression where when you put dot place is called as an attribute which actually holds the value of E. Now we will elaborately go into the next step. Now these are the productions and the corresponding semantic actions associated with each production. So the first production is when we have S tends to ID is equal to E. Now we just try to make a lookup. So lookup is actually a procedure where it actually searches element or a variable inside a symbol table. And if that if the element is actually found in the symbol table, then p value will not be equal to null. If p value is not equal to null, then we will actually transform the value of the element to e dot place. Else, it will be resulting in an error message. So next production is e tends to e1 plus e2. Now in this case, e will be having a temporary variable. A new temporary variable will be generated. For instance, it will be t1, and then we will take e dot place. E dot place will be composed of e1 dot place plus e2 dot place. Now when we go for the next production, e tends to e1 star e2. Now similarly, we apply for e dot place will be generated a new temporary variable. So if this is the second expression, then a t2 temporary variable will be created here. And after that, a 3 address code will be generated where e dot place is equal to e1 dot place star e2 dot place. Now if e1 tends to e tends to e1, then e dot place is equal to e1 dot place. Now the final expression is when we have a production e tends to id, we will look into a symbol table whether the corresponding identifier is present in the symbol table. If it is present, then p value will be taking the value of id. P value is obviously it is not equal to null, then p value will be getting transformed to e dot place. If p value is equal to null, then it will report an error message. So this is about the semantic actions associated with the production. Now we will look into actual problem here. So perform a syntax directed translation for a statement x is equal to a plus b star c. Now this is an assignment expression. So on the right side we will have b is multiplied with c, then it is added with a, then final result is getting stored in x. Now we will transform this expression into a tree by the set of available productions in this case. Now the first is we will transform s tends to id is equal to e. Now this id is going to hold the value of the result. For instance, in this case, x is going to be the result here. So now on the right side, e will be getting abbreviated as e1 plus e2, and then this e2 will be abbreviated as e1 star e2. Now this e1 is going to hold the id values. E1 is going to hold the id value. For id, this id we will have a. So we will be replacing this id by a. Then this e1 is replaced by id. and that will be replaced by B here, and then this E2 have an ID and this ID represents C here. Now we have transformed this entire assignment expression into a syntax tree. Now we'll try to convert that into a semantic tree. So we will try to apply this expressions one by one. Now when we take up the first one, so we will take this, we cannot take id equal to x because until the right side is getting evaluated, so we cannot take this id x cannot be evaluated this. Now we will come to this portion, e1 tends to id a. So now when we take this portion, obviously it is equivalent to the production called as e tends to id, which is given there. Now, so what is this e1? E1 is E1 dot place is equal to A, because ID is actually holding a value called as A. So this ID represents A. So E1 dot place is equal to A. Now we will come for this specific subtree, E1 tends to ID B. Now this, when we come for this one, now this ID is holding B now. So E1 dot place will be B. Now when we come to the last one, E2 tends to ID, where ID represents C here. Now this ID, E2 dot place will be C now. So this E2 dot place is C now because ID is actually representing C. Now we will come for this subtree evaluation, E2 tends to E1 star E2. Now when we try to evaluate this, the first thing we are supposed to do here is we have to generate a temporary variable. So E2 should hold a temporary variable. So we apply this rule, E tends to E1 star E2. So this E dot place is holding a new temporary variable. So this E2 is called as E dot place now. So we will just try to convert that. Now a temporary variable will be created. The temporary variable name is called as T1. Now the next step is we have to create a 3 address code for this. E dot place is equal to E1 dot place star E2 dot place. So in E dot place we have T1, in E1 dot place we have B, and E2 dot place we have C. So we have to generate a 3 address code like this. So T1 is equal to B star C. Now we'll go for the next one. So the next subtree is here, E tends to E1 dot place plus E2 dot place. So we'll take this subtree. When you take the subtree, now obviously this says that E dot place should be generating a new temporary variable. So E dot place is this place. So this will be generating a new temporary variable because already there is a temporary variable called as T1. So obviously it will be generating a new temporary variable called as T2. So this E dot place will be having a temporary variable T2. Now the second step is we have to create a 3 address code. E dot place is equal to E1 dot place plus E2 dot place. So what is E dot place? E dot place is T2. And what is E1 dot place? E1 dot place is equal to A. And what is E2 dot place? E2 dot place is equal to T1. So we will get a 3 address code called as T2 is equal to A plus T1. So that's what it is getting generated, T2 equal to A plus T1. Now we will come for the final expression. So the final expression is S tends to ID equal to E. Now we will evaluate this final expression, that is the topmost portion of the tree. Now this says you will try to look into the table called as id.name. So this id.name, this says that first look into the simple table called as id.name. So id.name is x. So p is actually holding x. So p is not equal to null, then p is equal to E dot place. P is equal to E dot place. So E dot place is actually called as T2. That will be stored in P. So P is equal to X now. So now we will get a 3 address code called as X is equal to T2. So that's what. Now this is the way of actually generating a 3 address code using the semantic actions associated with assignment statements. So thanks for watching a video. Have a good day.